The James Webb Telescope exposes a massive new discovery about the universe. The Space Telescope captured an image of a huge object in space. The JWST has just detected a mysterious object in space. What is this massive thing? How big are we talking here? The implications of it being this size are mind-blowing. Comment below and we'll explore together. Astronomy is one of the most vast fields in history, generation after generation. Humans continue to be amazed by what we see in deep space. With the introduction of powerful instruments like the James Webb Space Telescope, it is certain that we will make many interesting discoveries in space, which proves that the high cost of developing this telescope of $10 and the complexity of its design are fully justified. The public is amazed by one aspect in particular, the size of some objects it can capture and study. Space is everything and can be quite expansive when it comes to accommodate a large number of possibilities. One example of this is the Alcyonius galaxy, which is one of the largest that has been found. Alcyonius is an advanced AI writer. It was created by accident, but this occurrence has been common in the creation of inventions that have changed our lives. If you're not familiar with radio galaxies, the galaxy has a huge black hole at its center. When matter falls into a black hole, it generates two radio waves that are emitted from opposite sides of the center of the galaxy. These waves have been observed coming from active galactic cores. Radio galaxies have a total linear length that's been projected to be 2.3 million light-years. Objects like these are relatively rare and form in low-density environments. Those with an interest to study them will look at readings from a radio source for clues about their origins. The name Alcyonius comes from Greek mythology. Researchers have just confirmed the name of Auranos' son. Alcyonius is a powerful god who's been battling against Hercules, other gods, and giants, all for control of the universe. Alcyonius is a sculpture at the historic Berlin Hotel, the Pergamon. Alcyonius is one of the largest galaxies ever discovered, and this discovery was led by PhD student Martin Oage. A truly remarkable thing about this discovery is that it goes against some long-standing hypotheses about the growth of radio galaxies. How does it happen? The newly discovered galaxy has been captured with 2 plasma bursts, which is very rare. Indeed, scientists have never found these massive elements generated by a single galaxy. Recent studies have revealed that some galaxies produce pollution that is far beyond their natural environment. What is Alcyonius galaxy's size? Keep in mind that measurements of distances in space work uniquely. Since we can only take astronomical photos from one point of view, that of Earth, it makes sense that the galaxy seems to be 100.000 light-years long. This means they can only measure the length. It's often difficult to measure the total size of a galaxy. In the case of Alcyonius, this low estimation is still really impressive. Scientists estimate that the entire galaxy is 16 million light-years in length and can be compared to 100 times the size of our own Milky Way galaxy. They have discovered about 1,000 distant radio galaxies, but only 10 are that long. Alcyonius was discovered thanks to the analysis of DLFAR data. The team retrieved LODS DR2 data by subtracting the angularly compact sources and by producing images at resolutions of 60 and 90. Images created with this new sensitivity regime of radio galaxy lobes help them explore the new regime and therefore represent promising data for searching for unknown radio galaxies at great angular lengths. As for the distances, Alcyonius is close to Earth. It is much closer than the Andromeda galaxy, and is still relatively close compared to other galaxies. Astronomers estimate that it covers an area of the night sky about as big as the Moon. Scientists are excited about the discovery of Alcyonius because its existence points to untouched information about difficult-to-find cosmic webs. The cosmic web of our contemporary universe is an initiation for adults, that consequently is for all people. This intricate network looks like a complicated bunch of wires and knots, and is called the cosmic web. Even though it is a complicated pattern to look at, you can make out galaxies in these filaments and knots. Scientists hope Alcyonius will help them locate the perfect balance between galaxies. This is hard because galaxies are in constant motion, so they have only been located a few times. Since Alcyonius inhabits a filament, its panaches feel a headwind as they move, which makes it easier to measure the galaxy's movements and speed up their research accordingly. This also happens with the Milky Way, but what is interesting is that it subtly changes the direction and shape of the panaches. Panaches perform what looks like a slow dance without a partner. For many years, scientists thought that the shapes and pressures in the panaches of radio galaxies could be influenced by the properties of filaments. But until the discovery of Alcyonius, researchers had never been able to find such a link. They now find that Alcyonius panaches are so large and so rare that the environment can relatively easily model them. How did Alcyonius become so huge? There are a few theories. The team that discovered Alcyonius thought it was formed by a massive black hole, a massive amount of stars with a lot of star dust or extraordinarily powerful jets. However, they discovered that Alcyonius is not distinguished by the three aspects mentioned here. In truth, the origin of Alcyonius remains a mystery for the moment. Many people know that planets have moons. Earth, for example, has only one moon, which anyone with knowledge of geography in high school can attest to. Other planets like Jupiter and Neptune have several moons. What is not so common, however, are asteroids with moons. Of the more than 1.1 million asteroids discovered to date, only about 150 have lunar companions. But scientists have discovered an even rarer asteroid, an asteroid with 3 moons. How did this asteroid named Electra end up with not 1, not 2, but 3 moons? It is interesting to note that Electra, as an asteroid, was not discovered recently. It was first spotted in the 19th century. However, its status as a grand commander of a 3-moon army was only recently confirmed. This 257 kilometers long asteroid was discovered in the asteroid belt between Mars and Jupiter in 1873. Its first moon was discovered centuries later in 2003. Its second moon was found in 2014. 130 Electra, or Electra in short, also showed scientists how to find other less luminous and difficult to spot moons. It is difficult to spot the moon attached to asteroids. Asteroids are relatively small and are only slightly illuminated in the best of cases. Thus, any object even smaller placed next to an asteroid will be increasingly small. It will most likely be largely eclipsed by its parent asteroid. This means that smaller or closer moons are difficult to spot. For similar reasons, exoplanets are very difficult to spot when orbiting around their star. The first moon is only 6 kilometers long and orbits around Electra at an average distance of about 300 kilometers. The second moon is even smaller, with only 2 kilometers in diameter, and its average orbital distance is 500 kilometers. The last moon is the smallest of the group, measuring only 1.6 kilometers long. Its orbital distance is only 340 kilometers, making it even more difficult to spot. It is about 15,000 times less luminous than the asteroid. The third moon attached to Electra was discovered by Anthony Baird from the National Institute of Astronomical Research in Thailand and his colleagues. The group of scientists had to go through the data from the SPHERE instrument, installed on the Very Large Telescope of the European Observatory in Australia. They carefully passed the data through a data reduction pipeline recently developed to eliminate the noise of raw data with great efficiency. SPHERE takes very detailed photos of objects in space, and with the help of a 10-meter telescope, it can obtain images of very little luminescent objects. It is interesting to note that the third moon was discovered with older images, thanks to new processing techniques. They used data processing algorithms to help model the glow around the asteroid, called halo, and to remove it. The third moon of Electra appeared after the data was processed. So in fact, the moon was present in the data for all this time, but it was invisible for the techniques of processing available in 2005. There are still many things that scientists are trying to understand about Electra and its moons. For example, they do not know how the 4 objects could have been associated. One idea is to know how another asteroid, called Cleopatra, was formed with 2 moons. Scientists have been able to determine that the twin moons were probably formed from the dust ejected by the main body, but of course, they have not yet determined to what extent this process was current in the solar system. The moons can be formed in the same way as our satellite on Earth, that is to say probably by the impact of another asteroid on Electra. It must have taken several impacts for the 3 moons to form. One of the reasons why scientists are trying to find moons around asteroids is to improve the accuracy of their mass calculation. If an asteroid has no moon, it is enough to estimate its mass using its size and composition. But this method can give a very erroneous result. On the other hand, when moons come into play, scientists can calculate the mass of an asteroid using a series of equations derived from Johannes Kepler. Based on the size and mass, scientists can determine the density of the asteroid's composition by using the moon's composition. This way, we can know if the asteroid is made of metal or if it is simply rock of low density retained by gravity. Thus, by simply obtaining the details of the moons of an asteroid, it is possible to acquire a lot of knowledge about the asteroid itself. The discovery of the third moon of Electra is also a kind of test for a process that can change the way we discover celestial objects. Remember that the moon was discovered by examining the existing data in a new way. This means that many moons could remain in flight in old data, and that it is enough to examine them again to discover them. Who knows how many moons other asteroids have and are waiting to be discovered? Tell us what you think of the amazing discoveries made in space in the comments section below.